The Road to Autonomy is presented by the Road to Autonomy Index. The Road to Autonomy Index is a rules-based equity benchmark index that measures the performance of a basket of global companies that are involved in the development and commercialization of autonomy. Institutional investors and fund managers are watching megatrends that are shaping investment opportunities today. These megatrends are creating thematic investment ideas and opportunities for forward-thinking investors. We believe that one of the biggest megatrends today is autonomy. That's why we created the Road to Autonomy Index, the world's first and only pure-play index to track the thematic investment opportunity in autonomy. Follow the Road to Autonomy Index on your favorite finance app by simply typing in the ticker Autonomy. To learn more about the Road to Autonomy Index, visit roadtoautonomy.com/index. Hello and welcome to the Road to Autonomy. I'm your host, Grayson Brulte. On today's episode, we're absolutely honored to welcome back Matt Soule, CEO and co-founder, Parallel Systems. Matt, welcome to the podcast.
Thank you, Grayson.
It's great to have you here again because, as I said the first time, and I'll say this again, Parallel Systems is building the future of freight rail. It's been roughly a year since you last joined us on the Road to Autonomy. How has the Parallel Systems business evolved over that time? I read the press clippings. It seems like you're making a lot of progress.
Yeah, we're very busy. We've been testing our Generation 2 vehicle, a lot of track worthiness, braking tests, and we're looking forward to bringing that vehicle to Colorado sometime early next year to Pueblo, which is kind of one of the gold standards for testing rolling stock. But we recently shared that we are working with Genesee and Wyoming to pursue a pilot in southern Georgia outside the port of Savannah. So we have an application with the FRA to do that. We are about to test platooning, which is a core aspect of our technology. We'll be testing that in a few weeks. And we also have a vehicle deployed internationally right now, but we're not quite ready to talk about what's going on there.
All right. Well, then you're coming back for the third time for the international one, and I'll leave it at that. Pueblo, Colorado, why is that the gold standard for testing? Is it the terrain? Is it the altitude? What is it?
That's a really good question. I don't know the origin of it, but there is a facility there called TTC, which is owned by the Department of Transportation. It was formerly run by an organization called TTCI, which is part of the Association of American Railroads. The DOT renewed the management agreement with another company called ENSCO. And so TTCI rebranded as MXV Rail, and now they're building their own facility in Pueblo. So someone at one point said, we're going to build this rail facility in Pueblo, and I don't know the history of that, but it seems like everyone's committed to Pueblo being the test center. So now there's going to be 2 test centers in Pueblo to support testing of rolling stock.
What type of testing are you going to do?
The core testing is really around track worthiness. So you think of like an automotive test ground where you are inducing like different dynamic stimulus, like you have different terrain, different grades and other conditions to see how vehicles perform dynamically. And these railroad testing grounds are very similar to that. They'll have different curves, different speed tracks, and we will run our vehicle through a series of tests there to most importantly validate the models that we've already built up to predict how the vehicle will perform. So we'll be able to run at different speeds, have different dynamic conditions, and see how the vehicle responds and see if it's consistent with what we predicted. And then that will give us more confidence in the model that we have, and we'll be able to predict how the vehicle handles in other types of scenarios. We'll also be just looking at braking performance. The test track we're using in Southern California right now, it's on a condition to allow us to really go at high speeds. And so one of the nice things about going to Pueblo is to be able to go at faster speeds and then see how our braking performs at those faster speeds too.
Will you test your platooning applications there? And the first time you're on, you talked about how your parallel systems, they could break apart. And will you test that as well?
We're going to be testing that first here. That is under consideration to test in Pueblo as well. But the minimal thing we'll be testing in Pueblo will be how a single vehicle performs dynamically. But the first and most important thing is that we do that platooning testing here, and then we'll see if it makes sense to bring that to Pueblo as well.
I'm a little kid at heart, so I got to ask, you're out in Pueblo, and there's that great kids book, The Little Engine That Could. I think I can, I think I can, I know I can, I know I can. Do you have a big steep hill that you think I can, I know I can, that the parallel system vehicle has to get over in order to succeed?
Obviously, what we're doing is very, very different from railroading in its current form, and I think that is an obstacle for us to climb. I would say we have a lot of interest, but to deploy what we're doing widely requires a big shift in thinking about how rail can be used. So if I have to pick one hill, I think that is the biggest one for us, is to really influence how people think about rail services and how a platform that Parallel is developing can not just work alongside existing trains, but also allow railroads to do things differently. And as you know from last time we talked, we're all about expanding rail's addressable market and giving railroads the tools to compete more widely for freight business.
When you're looking to compete with freight business, you have the G&W, the short line rail company. You have a 211-mile route between the Port of Savannah and Macon, Georgia. Is that an example where you're trying to get more of that intermodal business on those 200-mile, 300-mile runs or shorter?
This is a versatile platform that can solve a number of challenges for rail, but the fundamentals of this are that rail's architecture requires large scale to accomplish truck competitive unit economics. These massive trains that are going from like LA to Chicago, that scale is what makes that service truck competitive. Shorter trains have better quality of service, but they get more expensive because that fixed cost of locomotive and crew is being amortized over fewer units of freight. And so as a result of that, think of freight lanes as permutations of volume and distance. So rail does a very good job of serving large volume freight lanes that have a lot of distance in them. The reason for that is because you need to park these big trains in a large terminal, and these large terminals are frequently not close to where your customers and shippers are. So you can have a pretty significant drayage component, the first and last mile trucking leg of that. And when the door-to-door distance gets too short, the drayage costs just dominate. And the rule of thumb in the industry is you don't put it on a train unless you're going at least 500 miles. And what Parallel is working to accomplish is truck competitive unit economics at smaller scale that allow for smaller, more innovative terminal solutions that can get closer to customers and shippers and push those drayage costs down, which is a key part of allowing rail to expand their addressable market. The other challenge for rail when it comes to volume is that this large scale that trains need to operate at, the accumulation period can generate unacceptable service quality for a lot of customers. The accumulation period might be uncertain or just too long. A lot of shippers who want to delegate things to rail generally want at least one intermodal ramp arrival and departure time per day. And when the volume's too low, it's very hard for them to meet that commitment. And so again, with Parallel smaller scale, we can serve freight lanes that don't require massive volumes to have that daily arrival and departure. So that's the core of our strategy. And so when you look at this lane in Georgia, it is shorter. It's well short of the 500-mile rule of thumb. And the volume might not be necessarily as high as rail would conventionally serve as well. We do see interest in moving things from Cordele back to the port. Like there in the past, there's been intermodal services between Port of Savannah and Cordele. But the volume is probably a little bit lower than what rail would normally serve. So what Parallel's platform would do is help make this a feasible rail intermodal lane in southern Georgia and help shift trucking activity, especially around the port, shift more of that to rail.
I had a friend of mine who was at the Port of Savannah 2 weeks ago, and he said, you have no idea how many trucks were coming at that port to go to that inland port that they're building. The whole highway was just trucks, so you'll eliminate trucks off of the road. Are you able to do that because of the massive, I repeat, massive inefficiency there is in the railways being occupied? Because less than 3% at any given time of the railroad is actually used. So you got a 97% opportunity there. Are you using that inefficiency to your advantage?
One of the advantages of our platform is that we resolve some of the reasons why the in-practice utilization of the network is not as high as the theoretical. And so one of the reasons is that you have these very big trains that can be complex in building them and even getting them to depart successfully. It's not uncommon for a train to be assembled in a terminal, but the locomotive that's supposed to pull it hasn't arrived yet because it's attached to another train that's late. And so lateness can compound in that regard. So what Parallel's platform helps as an advantage in helping network capacity is that our platoons entering the network are not gated by availability of power or crew, which are real limitations for rail today in its current form. Another consideration that's limiting capacity a bit is that as these trains get bigger and bigger, the number of sidings for trains to pass each other becomes more limited because the sidings equally have to be as large to accommodate these large trains. So there's a bit of a constraint on capacity because of the ability to actually have trains enter the network on time, the number of passing opportunities. And so with a platform like Parallel's, we can always be ready to respect this time slot because of the architecture of what we're building. We can also be more flexible because we can make or break platoons. We can opportunistically slide into multiple sidings if we had to. So those are some examples of things that we're able to enable that can help drive that capacity up higher.
Let's look at a large railroad, BNSF, owned by Berkshire Hathaway. They're building the Barstow International Gateway Complex to connect LA to Chicago. It's 130 miles from the ports of Los Angeles. Do you partner with BNSF and say, hey, BNSF, we have an opportunity for you to fully maximize your international gateway complex instead of waiting for the big BNSF trains to go from the ports all day?
A use case like that, we see the opportunity is we could replace the long dray that happens from trucking to feed into that terminal. That's one of the services that we see is rather than trucks draying a container 50, 100 miles to a conventional intermodal terminal, we could actually move that box by our platform, by rail, and feed it into that terminal. It's an opportunity to actually increase conventional rail intermodal services by just feeding containers in and out of it for less cost than you do today with truck drayage.
And I want to dive into this. Your co-founder did a brilliant interview earlier in the year about around the ports of Los Angeles, Long Beach, San Pedro. Your co-founder mentioned that there's railroad tracks that are trenched with no grade crossings, no road intersections, yet the tracks are massively underutilized, going from the port of LA into the Inland Empire, which has over 4,000 warehouses, one of the largest industrial complexes for warehouses in the United States. Why is that inefficiency there? It was obviously built to move stuff. It was built to be safe, but why?
I think it was built at the scale it was because everyone was motivated to get more things to rail. Unfortunately, because of some of the things we talked about, that really hasn't materialized. Another consideration too is that the available real estate to load and unload containers on a conventional freight train around the ports is very limited. And so there are limitations around how much container volume can be handled, not because of the network itself, but because of the ability to access it through terminals. The ports are looking at ways to improve that, but that is probably one of the biggest limitations right now is that real estate, that terminal to actually move containers on and off the trains. And that's another consideration for just the network capacity as a whole is the network is also probably more limited by terminal capacity than network capacity right now. If that's your choke point, you're not going to get any more containers on if your terminals are operating at max capacity.
Your system, I'm assuming, has a smaller real estate footprint. In hypothetical world, you can get deployed at the ports and operate efficiently.
The opportunity is because of our architecture does not require the massive scale. It supports having higher asset turn. So we come in to a terminal or port and at a scale of maybe 20, 30, 40 vehicles, 50 vehicles is our max platoon size that we're designed to right now. 50 vehicles is about half a mile long compared to a 3 mile long train. So it's still quite big, but it's smaller than conventional rail. What that means though is that we can spend less time loading and unloading because we're dealing with something that's a sixth of that distance, a tenth of that distance, a tenth of that size. And we're able to move out and clear the way for other platoons to come in. And so that asset turn, I think, is really key to reducing the footprint for this loading and unloading.
Will loading, unloading be autonomous as well to fully optimize for efficiency?
It's certainly something we are looking at. When you look at double stack containers, this is how rail primarily moves containerized freight is you stack 2 containers in a well car. That double stack operation is a hard thing to automate right now in its current form. But if you are working with solutions that are single stack, I think the path to automating that or having high levels of autonomy anyways are very straightforward. The double stack operation requires someone to place what they call an IBC, an interbox connector between the boxes. And that right now, that's a manual operation. I know people have looked at automating that, but that would be a necessary step to be able to automate double stack.
How has the Federal Railroad Administration been towards your technology? Have they been receptive? Have they been standoffish? Or are we looking at the same things happening with the self-driving car side is happening to you with a lot of distrust? What has that been like?
I think it's been a great working relationship. They've asked a lot of good questions. They've been out here for demos, evaluating how we're thinking about the technology. Safety is always the most important thing that we have a mutual interest in that we talk about. But I think it's been very effective so far in terms of what we've been able to share with them and the questions and insights that they've shared with us.
How about around the sustainability, since your system is autonomous and battery electric? Is that a selling point for them, getting over the hump? Hey, here's a more sustainable option than the traditional rail or trucks?
That's a priority that I think is really trickling down to multiple levels of the federal government because of the Biden administration's priority around it. So the FRA's mandate is around safety, but it is something that they're very aware of as a priority for this administration. And I think the case for rail in terms of addressing this problem is very, very strong because of rail's energy efficiency. I think that is something that is sometimes overlooked. We're looking beyond electrifying the current paradigm. Let's celebrate the energy efficiency of rail and actually have true CO2 reduction, because if we're using less energy, the energy that we require to charge that battery from the grid means that the indirect CO2 we generate from the grid side is lower. So our analysis is we're at least 90% less CO2 per mile than a diesel truck is today, because of rail is a quarter of the energy to move something compared to a truck. So even if you have a battery powered truck, the indirect CO2 is still quite significant. And then, of course, there's the whole zero emissions aspect of it. And this is very relevant for the impact on local communities. Greenhouse gases is a global interest, but our particulate matter, pollution, oxides of nitrogen, like those are local air quality concerns that affect the communities here. And so rail, because of the energy efficiency, the battery is smaller, but also rail's weight capacity means that we don't need to have the same weight constraints that trucking does in terms of electrifying. So it's a really great platform to deploy charging. And I think the captive nature of the network also make the economics for the charging infrastructure advantageous too. So there's a lot of like wins to put things to electrify rail and help make an impact on this.
Do you have to build out the charge network at the rail depots, or is there already existing infrastructure that you can tap into?
We do. What we've noticed, though, is that a lot of electrical distribution tends to hug rail corridors, but you do need to invest in charging infrastructure. But again, I think this is an advantage that rail has when you consider the alternative, which is trucking. Trucking is successful in its flexibility, right? That's a big selling point of it. But now when you're thinking about electrifying trucks, where do I put my charging infrastructure? Trucks flexibility actually is kind of at odds with that need. And so the captive nature of rail means I have a service design. I'm going between terminal A, terminal B. I know exactly where to put my chargers because my vehicles are always going to be there. So it's a quarter the size charger, and my utilization of that charger becomes more predictive. But you do need to still do those grid interconnects and hook up chargers just like you would for trucking. But being able to place it with more certainty, I think, is a big advantage.
You have the energy, you have the space, because you do have space there, and you're in a controlled environment. You don't have to worry about somebody coming off the block trying to use it off the street, because I think that's going to be an issue with trucks, that you might get an individual who's confused that tries to charge it, or you're going to get somebody that's going to, I'll give you the Bill and Ted bogus adventure. They're going to try and plug it in, and then, oh, this is going to be great, it'll charge faster. But then you have headaches and you have slowdowns around that. So let's just use the ports of LA, because you're based in Southern California and LA, to Fontana, roughly 70 miles, some of that going out to 120 miles each way. Do each one of your vehicles get charged when they get to Fontana? Or how do you charge all the vehicles together? Or does it run all day and then it just goes to home and goes to sleep at night and charges?
The service design will help answer some of those questions. And at the end of the day, a lot of these questions come down to economics, because you don't want to dwell your assets unnecessarily to charge. So what we're building right now will have a range of about 500 miles between charges. And the way we're conceptualizing this is because you do have to dwell to unload and load a container from our platform. That is a great opportunity to charge. And we're not moving single containers too, we're moving in platoons of 20. So if you look at the dwell time for a platoon of 20 vehicles to unload and load, it just so happens that dwell time is going to be a couple hours. And that is incidentally about the ideal time to charge a battery. So when we go into a terminal, we will have charging nests, kind of like a robotic vacuum cleaner, right? Going to those charging dock alongside the rail, and the vehicles will go to those locations and automatically dock with the chargers. And while they're charging, the freight is unloaded and loaded. So exactly where, for that hypothetical you just gave, like exactly where those chargers would be located, we'd have to dive into the details. Maybe the energy costs or cost of hooking it up to the grid are lower in the Inland Empire than at the ports. So that might be the better place to put it. And I think generally through the ports, you want to hustle in and out of there as fast as you can, right? Because of all the modes of transportation that are coming to that place. So just, spitballing with you right now, like probably would make sense to put the charger in the Inland Empire and just try to move in and out of the ports as fast as possible and get back to the Inland Empire and charge again.
Because you could technically build a microgrid out there, and the land is much cheaper out there. You have more abundance of it. The energy is probably cheaper than the port. That becomes really interesting. I'm going back to efficiency because you're really efficiently operating, that you're taking out all the what ifs. So your vehicles will go somewhere to sleep or to charge or have a snack. There you go. Use the term. They're going to go there to have a snack. Do you come in there with a blueprint to your partners on how to design that terminal? Do you have to use the pre-existing infrastructure where they can go have a snack room, or what does that look like?
It's early days, but service design is something that we're building up as part of our own capabilities. And we've done some early work on that, and not just totally in-house. We've worked with some outside consultants like academic groups. And so it's a core part of what we're developing. We're not just throwing the technology over the fence. We're getting very involved in looking at the balance of terminal capacity, network capacity, productivity of our assets, looking at how the charging economics work. Because at the end of the day, like, economics drive this entire industry. No one's no one's paying for virtues. So we have to be very competitive in the balance of price and service quality. And so that's why we've stepped into this role. And like long term, we hope to educate the industry to be able to do this independently. But you're talking about the biggest hill earlier for us to climb. And like that's how we're starting to manage this risk is let's be proactive and start engaging deeply in service design aspects of this very, very different capability and work alongside them to show them what we think is something that can be realized.
You hit the nail on the head, and I'm a big fan of your company. And the reason why is because you're so focused on the economics of how to make a business and how to make it profitable. A lot of individuals in technology, economics goes in one ear, goes out the other. Okay, next. But you're actually sitting there and you believe it, and you eat economics for breakfast. And some people have Wheaties and you have economics because that's what's going to make your business long-term successful. Do you envision your customers running these on fixed routes, or they're going to go, say, back port to warehouse? Are they going to run them in different scenarios? How do you envision your customers deploying your system?
Early days, we think it'll be set routes as parallel, and the industry wants to build up a deeper understanding because as you start making these assets more fluid, like the complexity is going to go up exponentially. And if you look at how railroads operate today, the locomotives especially are very, very fluid across their network. They're not just like ping-ponging between a certain origin destination pair. But early days will be captive. We expect to be captive to a particular railroad. Interchange is like a long-term horizon. And likely it'll be a specific lane that's set up to serve a specific customer's interest. Could be just a new domestic intermodal lane, or it could be taking something directly to a customer's dock. There's a lot of possibilities here.
When you look at, there's a lot of possibilities. So you have a 500-mile range. Do you try and look at applications, say 300 to 400, just so you have that extra battery just in case of weather or a situation might arise that you haven't predicted?
Yeah, you don't want to like coast in to the terminal on fumes. And that's part of like the service design aspect too is, okay, we're going to dispatch this platoon and you want to have a high degree of confidence that you're going to be able to arrive there with sufficient energy margin. So how much reserve capacity we want to have left, I think, is going to depend a little bit on the service design, but also depend a bit on us evolving our technology. Like, what is our confidence interval on our state of charge estimation? And that's still something we're working on. But yeah, you want to have a little bit left in the tank. That said, when we think about service design, rather than possibly customizing the vehicle to have variable battery capacities depending on the range or grades that a specific route might demand, I think it likely makes more sense for us to have a pretty consistent asset and then deploy charging stations more frequently depending on what that service requires. Like if you're climbing through the Sierras, like you're going to have to stop and charge a lot more frequently. And so you would, in that case, likely deploy more frequent charging stations along the route.
And then in your models, do you have to build in battery degradation into those, since your batteries will be going through high use industrial applications?
Yeah, we're fortunate in that, again, because we don't have the weight sensitivity that trucks do. We have the luxury of being able to select battery chemistries that degrade at a slower rate, especially when you look at like high charging scenarios. But absolutely, we want to look at end of life, and that is going to be part of the onboard state of charge estimation. Is not just how much percentage do I think is left, but how much absolute joules do I think are left in the battery based on like how old it is, how many cycles it's been through.
Fast forwarding to a commercial world here, is this where you have a command center where you have all the data on the screen and either one of your customers or one of your employees is monitoring all this data in real time as your vehicles go down the tracks?
Yeah, that's still early days on whether or not it would be parallel or a customer, but we are working to develop train control integration so that our platoons operate alongside conventional rail. And so a dispatcher, which is a job today in the rail industry, is still granting movement authority to our platoons just as they would like a conventional train. We are autonomous within that movement authority, but if there's an exception, anything that the onboard system thinks either is a hazard in the rail environment or there's some telemetry from the vehicle that generates a concern, beyond like, okay, the bearings are wearing out, let's schedule this to come in for preventative maintenance. Let's say like an axle temperature is reading too high. That would likely summon someone in a back office setting. We call it an exception handler, who would likely review the data and assess what to do. And that'll be an evolving capability for us. But there's, as an example of like the new types of work that we see being created is having someone go to an office environment who is able to look at these dashboards. And if there's like a check engine light that activates from these vehicles, there's a person who's on standby who can dive in and help assess that situation.
And then you're creating jobs, but most importantly, you're creating the efficiency for the uptime. You're taking out the guesswork. Is this going to work? Is this going to work? No, you have the efficiency there. When you came on the first time, you had the Gen 1 vehicle. Now you have the Gen 2 vehicle. What were some of the major improvements and updates that you made to the Gen 2 as compared to the Gen 1?
Pretty much everything, I think. The Gen 1s were very scrappy prototypes as a test bed, proof of concept to ourselves, but also people from industry who wanted to come out and see what this is about. I mean, we took conventional rail truck assemblies like steel bogies and we just like welded on it, like added traction motors, batteries. And the powertrain was not ideal. We had a chain drive, which we knew was suboptimal, but because it has backlash and it has elasticity in the chain. And what we do to position things for a loading unloading operation is like more like a servo type of design. And with that chain drive, it's hard to get the controller right. So everything on the Gen 2 is ground up. So we designed our own trucks, integrated batteries, integrated traction motors and axles. We are not there yet in terms of arriving at our final solution. This is a track-worthy platform that we want to get out into the real world to get data for ourselves to help inform the commercial version of this vehicle, which is coming next, but also to demonstrate what are the most important aspects of this technology, its ability to integrate alongside existing freight rail operations and to show integration with train control systems and infrastructure in a real world environment. So that is what we're looking to learn from these pilots we're doing right now. But we will be evolving the design after this to basically drive reliability up and drive costs down. The cost is a bit high in this current generation vehicle because the chassis, for example, is a big steel weldment. So there's a lot of welds. Converting those bits of steel into this chassis is quite expensive right now. In longer term, we want to have the chassis is mainly castings. So you're pouring liquid steel into a mold, and conversion of that liquid steel into a chassis is much more efficient.
Is the Gen 2 vehicle in service today from a pilot perspective? Is it out there? Are you piloting it with your customers today, the Gen 2?
Right now, that vehicle is only in facilities that are not part of the general rail system. So we are testing at a site we have here in California. We've done a lot of our own track worthiness testing, brake testing, localization, everything. And we'll be testing platooning in a few weeks too when we have another vehicle there.
And then will the Gen 2 go into regular commercial service, or are you going to wait to the Gen 3? When I say commercial service, from a pilot perspective, will that be the Gen 3 that will do that?
The pilot testing is really about the testing rather than the service because we want to make sure we've got everything proven out. We're building a very strong safety case for what we're doing. So that's really the focus of the Gen 2. And then the Gen 3 will benefit from those learnings. And that will be something that we look to deploy to actual service.
The Gen 2, things that I want to highlight to our listeners, it supports standard size intermodal containers. Well done. Why?
We decided to put a spanning structure on it because the most important thing for us was to get out and assess track worthiness and train control integration and operating practices that are compatible with rail today. So we decided to minimize engineering scope and just put a spanning structure on it. So right now our vehicle is designed to accommodate a 40-foot container. That spanning structure could be customized to handle a 53 or another size container, but that's the simplest core product right now. And the most urgent thing we thought was necessary was to get that out there and get that experience and get that test data.
Trucks are going autonomous like your systems. Fast forward to the future, do you view autonomous trucks competing with you, complementing your business, working together? How do you see that evolving? Because you're both offering autonomous solutions.
I candidly think all three of those are possibilities. So I think autonomous trucks on their best day will very likely have better quality of service than what we're building will, but what we're building is going to have better quality of service than rail today in its current form, and I think pretty good quality of service. I think the advantages of what we're building versus trucks is, of course, the energy efficiency and climate goal benefits of leveraging the energy efficiency. And I think our platform at its core is always going to be less expensive than any on-road truck because of energy intensiveness, as well as like the sensor burden, the complexity of the environment that self-driving trucks have to operate in compared to what parallel is developing. So I think those are like two very, very worthwhile tools for the transportation industry to have at their disposal to design services around that. Some of what we're building, I think, can complement drayage very, very well because at our core, we are working to create smaller, more efficient terminals, which from the truck driver's perspective means that we get in and out more quickly. And if we're placing it closer to customer shipper, their actual travel distance is shorter. So the goal here is like more turns per day. And so whether that's a truck that's driven or an autonomous truck, the economics get better and better and better the more productive that asset is. So I think that's where there can be a real complement where a self-driving truck can handle the complex first and last mile if there's a service that doesn't require us to go directly to that customer.
You're both going to help shore up the supply chain. It's both going to be good for the economy. The economy, I'm nervous. You hear all these statements, soft landing, hard landing. I'm really not sure. But the one thing I do know for a fact, and we all do, the economy's slowing. Bank of America is out there now talking about that we're entering a labor light economy, and it's going to really accelerate as we go into this downturn. I call it the autonomy economy because autonomy is going to create a lot of jobs and be really good for the economy. With this economic backdrop, how are you preparing parallel systems to handle this? And obviously on the backside of that, there's a global push for automation that's only booming and growing.
I think regardless of people's perspectives on the economy, like you have to stay focused on priorities and objectives, and you have to watch your cash, especially for a startup. You got to keep a close eye on that. So we're looking to how do we scale to start taking advantage of this environment that you were just describing. It's like we see there's a strong need for decarbonizing transportation, but availability of labor to support future transportation needs is also a growing theme. And so I think this is a great opportunity for Parallel to look at how can we scale, how can we deploy our technology in a safe way that meets those needs.
At least you're getting 5% on your money now, but I'm going to put my investor hat on here. You're investable. As an institutional investor, to me, you're investable because the labor shortage is only going to grow and you're eliminating that problem and you're allowing businesses to scale. So I think it's tools like yours and this unfortunate economic situation are only going to prosper for a company such as Parallel. When are you projecting Parallel Systems to be up and running with full commercial operations? Are you a decade away? Where are you on that?
That's a very good question, and it's something we're actively working on right now. I mean, I think it's certainly not next year. What we have to get through is these tests, and these tests are going to inform this commercial vehicle. This commercial vehicle, I think, is going to be a couple years away, and then we're looking at how do we deploy it into these early applications. So we think it's very close. There's a few moving pieces, though, right now that make it hard to put a specific date on it, but it's something we're actively looking at, and we want to see it come to life as soon as possible.
Well said, and I like that you didn't give a timeline. I got to give you a lot of respect for that. I tried to get you to, but you didn't take the bait on that one. On the backside of that, no timeline here. At some point, you will commercialize. How's the regulatory environment? Is there a regulatory hurdle that you have to go through? Same thing we're seeing on self-driving trucks that you're going to have to go through on your side? So do you have a free and clear path from a regulatory standpoint?
There's absolutely work to do there. I mean, we're very focused on the safety of this, which I think is at its core is why those regulations are there. But within the US, the regulations, it's no mystery, they were not written with the intention for a technology like this. So there's work to do there. But I think the most important thing is focus on proving out the safety case, which is a lot of work to do. And that's one of the areas that we're growing our team is to expand our capabilities there. But we think that making a strong safety case, proving out in the most objective fashion possible, paired with the environmental and social benefits of what we're doing, make a very good case for addressing whatever those shortcomings might be on the regs today. I would say the main issue is that they're not written with a autonomous, self-propelled rail vehicle in mind.
Times are changing and autonomy is coming to rail. What you're going to do is you're going to have a very positive impact on the economy. The regulators have to realize that without autonomy, this economy is going to come to a standstill if Bank of America is right and we do go into a labor-light economy. Matt, in your opinion, what is the future of parallel systems? Where do you want to go?
We look at our impact and success about how much can we actually affect modal conversion. This is converting trucking activity to rail. So this is how we're going to look at our impact. You asked about our timeline for deploying, and there's still work for us to do to answer that, but that's how we're going to be looking at our impact is successfully converting trucking activity to rail and not just realizing the climate benefits of that, but also the benefits on highway infrastructure. You mentioned the Port of Savannah previously. A lot of successful ports have that pain as a result of their success is that there's a tremendous amount of truck congestion. A lot of ports want to strategically get more trucking activity converted to rail to alleviate that pain. And so those are examples of things that we looked forward to hoping to make an impact on and seeing some of that congestion be alleviated by solutions like ours and actually track how many miles is parallel doing, which we interpret as miles have been converted from trucking to rail.
Something tells me you're going to pull it off, and then you're going to have a lot of happy constituents in that district when you take trucks off the road and put the freight on rail. And you're going to increase the efficiency, and the economics are going to work. As we look to wrap up this insightful conversation, what would you like our listeners to take away with them today?
Probably the most important parts of our technology is that we're not looking to compete with rail in its current form. This is something we see as additive that complements rail. We want to provide a set of tools that allow railroads to go after more of the freight business and convert more trucking to rail. Trucking absolutely plays a very important role in this economy, and there's still a lot of activity for trucks to do. But this is about shifting some of that trucking activity to rail, and we're excited to be doing it. We're excited to be working with industry.
Parallel complements rail. The future is bright. The future is autonomous. The future is parallel systems. Matt, thank you so much once again coming on the road to autonomy.
Thank you, Grayson.
If you've enjoyed listening, please kindly rate, review, and subscribe on your favorite podcast platform. Want to get in touch? Follow us on Twitter, Instagram, and YouTube at Road to Autonomy, or email podcast@roadtoautonomy.com. The Road to Autonomy podcast is produced by the Road to Autonomy LLC. The views and opinions expressed on the Road to Autonomy podcast do not necessarily reflect those views of the Road to Autonomy, its subsidiaries, its shareholders, directors, investors, or partners. The content discussed on this podcast is for informational purposes only. It should not be taken as legal, investment, tax, or business advice. Nothing is a recommendation that you purchase, sell, or hold any security or other investment, or that you pursue any investment style or strategy. The content of this podcast is presented on an as-is basis with no warranties, express or implied, of any kind. Financial mentions about companies in the Road to Autonomy Index and discussions about the Road to Autonomy Indexes are for informational purposes only and should not be relied upon when making any investment decision. Furthermore, an inclusion of security within the Road to Autonomy Index is not a recommendation by the Road to Autonomy Indices LLC to buy, sell, or hold that such security, nor is it considered to be investment advice.